series that I know that you guys can do. Let's see. Adding 7 every time. Okay, great. So how do we get the next one? Okay, so the one we're looking for equals the one right before it plus 7. So if we're looking for the 10th term, or sorry, let's say we're looking for the 5th term, we just take the 4th term, 1, 2, 3, we take that one, right? And what do? We add 7. So we take that one, we add 7, that's the 5th term. So this is what we call the recursive formula. Recursive formula. Now let's talk about an explicit formula. Is this add 7, is this a common difference or a common ratio? Okay, it's a common difference, which is a slope, isn't it? Okay, it's a rate of change. And always remember, when we see a series like this is the first term, second term, third term, fourth term. What is the 0 term? Y'all with me? I heard one person say it. What is it? Okay. The initial amount, the initial term, or the 0 term, or the y-intercept, whatever you want to call it, is -4. So this equation is y equals 7x, or a sub n equals 7 times n minus 4. So in this case, like if we wanted the 10th term, can we just find it right away? We don't have to know the 9th term first, do we? Okay, so if we want the 10th term, if we want a sub 10, 7 times 10, subtract 4, that would be 70, subtract 4, which is 66, and this is what we call an explicit formula. So an explicit formula will tell us any term we want, anywhere we want. We don't have, it's not just, oh, here's how you get the next one. Okay? So that's one type of series you guys are good at. Let's look at another one. I think you know what's coming up, don't you? I think I'm doing this right. So what do you guys see here?
Times 7.
Okay, times 7. So this is what we call, it has a common ratio. So this one's not an arithmetic or a linear type equation. This is a geometric, or we've been calling an exponential type equation, right? Okay, so let's see. Let's do a recursive rule. The one I'm looking for, the next one right here, this is 1, 2, well, we'll say a sub n, just equals the one right before it. And what do we have to do to the one right before it? Yeah, we have to times by 7. So I'm going to put the 7 out here in front. So that's how we get the next one. We times by 7. Okay? But how do I get the 10th one? How do I get the 20th one without having to find all the ones previous, right? So remember our formula. Okay, so all we got to do is remember, okay, our common ratio is 7. Where does that go in our formula right here? A or B or X? B. B. Okay, that's your common ratio all the time, B. A is the initial amount, the starting point, the 0 term, which is kind of weird here. First term, second term, third term, fourth term. What is the 0 term? 3/7. 3/7. Okay, so we have our 0 term. We have our common ratio. There it is. So if I want the 10th one, if I want a sub 10, I just take 3/7 times 7 to the 10th power. How big a number is that going to be? Pretty big, pretty big. Okay, so 3/7 times 10. 7. Let me get this to work. 7 raised to the 10th power. And I'm just making sure that it does 7 raised to the 10th power before I multiply by the 3/7. Okay? So, whew, that's a big one. What is that? 121,060,821? That's getting up there in a hurry, isn't it? Okay? So, with this common ratio of 7, is this exponential growth or exponential decay? Growth. Okay? It doesn't matter. A doesn't matter. A can be anything. And it can still be growth or decay. That just tells you where you're starting. Okay? It's all about the common ratio. If the common ratio is greater than 1, it's growing. If it's between 0 and 1, it's decay. What if it were 1? What if the common ratio is 1? So my first term's 5, and the common ratio is 1. What's the next term? 5. What's the next term? 5. What's the next term? 5. Okay, so y equals the initial term, first term, second term, third. What's the 0 term? Okay, times the common ratio. What's the common ratio? 1. So you notice, what is 1 to any power? It's still 1. So this is just a horizontal line, isn't it? So this is not exponential growth or exponential decay. So in these cases, the common ratio is never going to equal 1. And it is never going to be less than 0. We're never going to put a negative common ratio in there. If you have a negative common ratio, let me show you what happens. Negative 2 to the 0. 1 times 3? Okay. Negative 2 to the first. Come on, negative 2 to the first. Negative 2 times 3? Negative 6. Okay. Negative 2 to the second power.
Negative 4.
Is it negative 4 or positive 4? Positive 4 times 3? 12. And then when I go to the third power, I get negative 8 times 3, which is negative 24. So do you see how our y's are alternating back and forth between positive and negative? So that's not going to fit our exponential growth or exponential decay type of situation, is it? That's going to be going something like that. That's not something that we want to deal with. Do you? See, Jim's got her hand over her face. She's like, oh my gosh, I can't handle that one. We don't want that, do we? So, what's this? Slope or? Rate of change or? Common difference. Very good. Okay. What's this? Y-intercept?
0.
The 0 term? The initial amount. Awesome. Okay. Okay. What is this?
That is the common ratio.
The common ratio. Okay, the common ratio. What's this? The y-intercept?
0.
The 0 term? The initial amount. It is confusing because we use b here for the initial amount, right? And the y-intercept. Here, b isn't that, is it? It's the a. So it's a little bad, isn't it? Sorry about that. I didn't make that choice. That's just the way it is. Okay. So when I give you a series like this, is that an exponential function? Yeah, because they're a common ratio, right? And is this exponential growth or exponential decay? It's decay, isn't it? Okay. And we know that because the common ratio, what is the common ratio in this case? Yeah, it's divided by 2, but what are we timesing by? Yeah. You always have to say, for the common ratio, you always have to think about what am I multiplying by, okay? What about the zero term? 16? So y equals, come on,
1/2.
hold on. Which is it? Y equals a times b to the x. Y equals, what's a?
1/2.
16. What's b? 1/2 to the x. Or if I write it this way, a sub n to the n. So we write it this way when we're talking about a series, like which number in the series are we looking for. But just an exponential equation, we can write it this way. And we can also say f of x. So remember y and f of x, same thing, right? Same thing. This should be easy. We've been talking about this. That wasn't a super long lesson, but we've actually gone over it for Wednesday, Thursday, and Friday as well. So this is chapter 6.2. Let's get that far.